Okay, hello everyone and welcome to this evening's online event. My name is Elvin Box, and I am privileged to be the chair of London Constructing Excellence. So we are delighted that you've been able to join us this evening, and we'd like to thank you for all your patience as this event had to be rearranged due to a technical hitch last week. The talk will commence in the next few minutes, with your questions being answered from no later than 6:45 p.m. and our session wrapping at 7 p.m. Please note our hashtag tonight is hashtag LCECZC. Two key points to raise before we start the presentation. One, as you are aware, for presentation purposes, you've all been muted. Please would you be so kind enough to turn off your cameras, as is the norm with our online events. Please use the chat facility throughout the presentation for your questions, which will be very, very gratefully received. If you wish people to know you are the author of a question, please ensure your name appears on the question. Thank you. Number two, please be aware that this evening's session is being recorded and will be available on our YouTube channel in the next 2 days. Okay, this evening, our guest speaker is Alex Edmonds, who is an associate director at the Robert Bird Group and has worked on a number of projects throughout the UK, US, New Zealand, and the South Pacific. While primarily focused on structural design, Alex has also undertaken advisory roles on seismic resilience, natural hazard mitigation, and building code development. Alex is currently engaged with the global remit to foster and promote digital design and innovation, and leads an internal team delivering digital and data-based initiatives for use by wider business and its client base. During this evening's presentation, Alex shall explain how digital techniques give consultants the opportunity to rapidly explore different design options and interrogate the outcomes against key criteria. This rapid optioneering, combined with data visualization to optimize the material quantities and embodied energy, enabling project teams to make informed decisions to achieve the best outcome for a project. London Constructing Excellence are delighted to have such a knowledgeable specialist for your edification and entertainment this evening. So without further ado, it gives me great pleasure to introduce Alex Edmonds.
Thank you, Elvin. So yes, as Elvin said, I'm going to do a bit of a walk through where I see the opportunities from digital design and digital engineering and data in assisting in our drive towards net zero. So just a bit of a quick contents of what we're talking about. So I'm going to do a little bit of a background on why we need to do or why we need to have the drive for net zero. Then a little bit about what digital design and data is and what I mean when I talk about those things, and then really dive into where I think it adds value. And I have a couple of case studies of things that have been done to try and drive some different options and things into various projects. And then spend a little bit of time talking about the barriers and opportunities for us all as an industry as we kind of try and embrace the digital age and then use that to assist us in our drive for better environmental outcomes. So one thing I have a couple of QR codes as you go through the presentation, which provide links to various publications that I've drawn information from. So feel free to click on those and you can get access to full documents and PDFs and reports, which provide a bit more context and a bit of background reading for those that are interested. I'm interested to know how that works. I thought it was a better idea for this kind of format of presenting. So hopefully that works well, and any feedback on that would be great because I've not tried that before. So right, bit of background. So I know Simon from Cundall's kind of went into the environmental impact of or the climate emergency that we're currently in a little bit last talk. But I don't think it hurts to continually reinforce the problem that we're in, and also outline that the targets that we have as an industry and what we really want to drive towards. So we are in a climate emergency. I don't think anyone is going to dispute that. There's more CO2 in our atmosphere than at any other time in human history. And we're on the path to exceeding 1.5 degrees C of global warming. And to stay below that, we can only emit another 500 gigatons of CO2 into the atmosphere. So for context, in 2019, we emitted globally 36 gigatons, and we haven't actually reached our peak. So at the rate we're going, our kind of current method of living, if you like, as a population, we're going to exceed the targets of 1.5 degrees C. And that's the sort of, those are the difference between 70 and 99% of coral reefs dying off as an example. So obviously, extreme heat events are happening more and more. There's numerous wildfires around the globe currently as we speak. And also sea levels are rising and Arctic ice is diminishing. So the Arctic ice sheets are at the lowest they've been since 1850. And all this also gives rise to the spread of diseases. So dengue fever is spreading as mosquitoes are thriving in areas where they previously weren't. So so it is it's a very serious topic for us globally as a population, and obviously this is sort of coming on the global leaders are meeting at the moment to talk about more about climate change. So it's obviously very relevant worldwide. The last 4 years have been the hottest on record. And I think the UN Secretary General put it, we're currently losing the race against climate change. But it is one that we can turn around. And there's a lot of discussion, the younger generations and our children are sort of challenging us and very much putting sort of the current sort of working population, if you like, on the spot to solve this, because if we don't, or unless we make some significant inroads into solving the problems, then it's too late for them to solve it. So it's not something we can leave for them to deal with. So we have to act now, really. So what impact do we have on it? Obviously, we all sort of work in the built environment. So where do we come in the overall context of climate change? So the World Green Building Council, so there's a link there to their strategy document. But some of the sort of key points that they pull out is buildings are responsible for around 40% of energy-related global carbon emissions, and also 50% of global material use. And that's only going to go up in terms of the quantities needed. The global population is growing. I think it's going to achieve something around 9 billion by 2050. And we, in this country, we have a housing issues where we don't have enough housing for people now, let alone in the future as the population grows. So it's a problem that's only going to increase unless we do something fundamentally different. So obviously the built environment as an industry has a big part to play in that. So to drill down a little bit more, there's a good report that was produced by the World Business Council for Sustainable Development, and again that's available on the link there, which they produced in collaboration with Arup. And that kind of tried to drill down into actually, if you look at actual buildings, what does that mean as we construct buildings? So they did a bit of a case study on 6 different kinds of building projects. And the sort of key findings they had were that, an average building, if you like, across the 6 was had about 1,800 kilograms of whole life carbon footprint of CO2. 50% of that came from the front end, so that comes from the embodied carbon during construction and design, the output of design, if you like. And that was fundamentally provided by 6 materials. So 50% of that sort of whole carbon emissions is coming from concrete, steel, reinforcing steel, aluminium, glass, and the raised access floor, which was an interesting one. So, as a structural engineer, obviously 3 of those items on that list are sort of part of my discipline, if you like. So obviously it's something that structural consultants and designers, we need to sort of step up and really take hold of that and try and address those issues. And the report also starts to ask questions around actually, if we, do we approach design properly? Should we actually be approaching it in a slightly reverse way than we do at the moment, where we actually look at do we need to build anything first? Is there something that we could, can you repurpose existing facilities? Can you build less? Can you build better ways, more efficiently? And at the bottom of that is kind of minimize waste. Whereas design at the moment, usually we start the other way around by trying to sort of minimize wastage in design, if you like. So It's definitely a challenge for us to actually rework the way that we think about design. There's also targets coming out from these publications. So obviously it's been talked about a lot industry wide. So 2030, we're aiming for 100% of new buildings to be net zero carbon operational, net zero, and then reducing embodied carbon by 40% from where we are now. And then by 2050, all of those by basically operational and embodied to be net zero. Some sort of more tangible targets around. So the RIBA, they're currently saying that we should be targeting 1,100 kilograms of CO2 business as usual, but with a target of 500 at 2030. LETI is 1,100 baseline, but getting to less than 600 for commercial office. And the GLA is targeting 950 and 1400 for the whole life, and then respectively, so aspirational targets for that respectively around 500 and 850. So compare those to the previous slide where we had those 6 case studies and the average across them was 1800. It's clear that what we do at the moment and our sort of standard design construction processes aren't going to be good enough at the moment to hit those targets. So we need to start doing something different. I think the whole life building cycle. So a lot of people have seen this before in various presentations, but this is really looking at where you address carbon. So obviously you've got the product stage up front, which is primarily design. So that's where you're specifying the materials to be built. Then there's construction, which is primarily consists of transport to site and then the actual erection of the building itself. Use stage, and then which is an operational comes into that quite significantly, and then end of life. So what do you do with the asset at the end of its life? And then sort of beyond that is the circular economy, which is actually can you reuse anything from the building itself and plug it back in at the other end in the project stage. Now, as we said, for context, 50% is coming from that front end. So it's coming from the product stage and the construction stage. So, if we wanted to target where we could make a difference and make a positive impact, then there's a lot we can do around that front end. There's something around 43% in the use stage and the operational energy side of things, and then the rest is kind of across end of life. Now it's interesting. I mean, if you talk to MEP consultants, they've been on this journey a lot longer than sort of us structures and architects to a certain extent. So, I think we're kind of sort of 15, 20 years behind in terms of trying to drive that 50% of initial embodied carbon down. The MEP industry has been doing that. They're kind of driving towards the operational net zero a lot faster than we have. So there's quite a bit of catching up that we need to do on the sort of front end design, if you like. And so what really impacts those, what are the decisions that we can make to try and drive that 50% down? Obviously choice of material. So looking at what kind of materials we're using, whether they're carbon intensive, low carbon, are there any new materials? And those are starting to come to more to light. Quantities, so looking at can we more efficiently optimize designs, are there loading opportunities, are the loads right, for instance, and then appropriate use material, waste, and then DFMA as well. So that's becoming quite, can we actually build and design things off site and then bring them on. Specifications, things like locally sourced, and then can we actually start to look at what our specifications are? Are we do we need to put more onus on the supply chain to drive some different manufacturing techniques in order to reduce the embodied carbon, and then looking more, as I said, at more off-site manufacture to reduce waste. So that's kind of where we are. So if we then think about how can digital and data help with those things, so how can we actually leverage the sort of technology which has become more to the fore over the last sort of decade? How can we turn that more in anger to try and help us solve some of these problems? So just a sort of brief pause onto what I mean really when I talk about digital design and engineering. So primarily when we talk about digital design at the moment, we talk about parametric modeling. So parametric modeling is sort of form finding and setting ourselves constraints and operating within those constraints. And basically, it's a bit of the sort of, what does the computer say after it's done a huge number of iterations to try and solve a problem which previously have taken us, may have taken us, months to solve, that we can actually plug into some software to actually try and answer the question for us, or at least give us an indication of what the answer might be. Interoperability, so all our software packages that we use across the industry are starting to talk to each other. Certain ones don't still, but there's a lot of pressure on them to start opening up the back end and allowing user interface into the sort of so that we can start to plug and play all the different software packages together. Efficiency tools, trying to find efficiency in structures and in forms and just in the way that we work. And visualization tools as well. So those augmented reality, virtual reality, and mixed reality. So, how can we actually start to visualize what we're building before we build it, and use that to make some decisions. None of these concepts are new. So, we've been doing this for a very long time as engineers. Admittedly, Gaudi used to do it with chains, and that was probably the first time where anybody, he was the first one to really try and drive efficiency in structures and try and reduce material wastage. And he did it, he did it on the Sagrada Familia with a hanging chain system, by hanging sandbags off chains, and that finds the most optimal form of the structure. And what you then do is if you flip that upside down, everything's then in pure compression, so there's no bending in anything, which makes it very, very efficient. And he was doing that sort of physically with physical models. The amount of computational power we've got now means that we should be sort of turning those kind of tools in anger on every single project we do to try and find efficiency where we can. Data science is the other one, which I think sort of fits quite nicely into trying to drive towards more sustainable outcomes. So, and that's really, data mining and visualization. So actually, we produce a huge amount of data now when we design and deliver documentation. So, there's a lot of information there which we can use, and we can use it all throughout the design process as well. And then off the back of that, what do we do with that data? So there's a lot of technology being developed now around artificial intelligence. So, helping us to identify trends, machine learning, which then comes on to actually, if you start to data mine a number of projects, you can start to identify benchmarks and best practice and then start to triage current projects against that. And then into sort of deep learning, which is getting really into sort of almost being designed for you to try and find the optimal outcomes for you. So those are the kind of technologies that we've got at our disposal at the moment, and there's many, many more. So I'm just kind of touching the surface of them in this. You could probably talk for hours about each individual one, and there's all kinds of subsets of those as well. But those are the kind of technologies that we have, and so then we look at where do those things start to add value. So where can we actually turn the technology to try and drive down that 50% of embodied carbon in the design. So I'm pretty much going to talk primarily about where I see the opportunities in the sort of product and construction stage. There will be ample opportunity to turn these in anger in the use stage and end of life. But again, as I said, there's a huge amount we could talk about on this, and so I'm going to try and concentrate a little bit on some case studies and opportunities that I can see around the sort of design and construction points. So if you think about a sort of a standard project as we go through, as in terms of the timeline of the activities that we do from start to finish, during the concept, there's a lot of opportunity to look around, whether we can refurb and reuse. Can we use digital tools to develop concepts, looking at geometric layouts, looking at form found and materiality as well. So, there's opportunities we can take to, rapidly flick through different materials and look at the outcomes of each one of those, so that we can make better decisions really about, where do we want to go with the building. And we also start to bring data together. So we're starting to look at feasibility data. So, again, that's pulling out things like GIA, NIA versus material quantities and carbon quantities. We can start to pull in precedent data. So looking at information that's come from previous projects and comparing those against the aspirations we've got for that particular project. And then starting to sort of form our concept based on from an informed point of view. as we go into sort of develop design, we're starting to look at things like frame optimization, element optimization, and then we're looking at more at quantity data and embodied carbon data as well. So we're starting to pull out more information through those stages. Again, into detailed design, we're continuing to optimize elements, and then starting to push documentation out and look at construction sequencing and whether we can optimize the construction sequence to reduce the amount of time we're spending on site, because obviously we've got, there's operational energy from running a site, and if we can reduce the construction program, we can start to save on those operational energies as well. And we also start to pull out more data. So again, we're now pulling out embodied carbon data, and also the machine learning data is where you start to pull information at the detailed design stage, sort of before construction, which you can then start to plug back into the next concept and next prelim. Through construction, there's obviously monitoring site data and all that kind of stuff that we can begin to pull, and also looking at monitoring the construction against the design. So are we achieving what we set out to in design in terms of material quantities? Use as well, there's usage data. And then into demolition, looking at opportunities for recycling and material quantities, and whether or not we can dispose and reuse. So those are the kind of the areas throughout the project where we can use our digital technology to try and drive a better outcome. So if we start to think about what that means practically, because obviously those are very, very high level, what are the actual opportunities that we can find? So very early on, if we're looking at a site, looking at reusing assets, we often make the decisions. Is there opportunities to refurbish the buildings? Could we look at facade retention, or could we look at extending up and just adding more stories? So and often one of the real questions that get asked with that, assuming that you're not trying to build a sort of 200 story tower on a site which has got a building that's only 6 story, because obviously there's we're straight away you're looking at demolishing and rebuilding. But if you do have an asset which the question is, could you be reusing it? Could you extend it upwards? And there's a lot of buildings across London in particular which there's space to extend, and there's definitely capacity in the structure. The question then comes to actually, what might it look like if you did go up? And there's sort of technology around at the moment in your phone which allows you to do very quick site surveys. So this is so anybody that's got the iPhone 12 Pro currently has a LiDAR scanner in their pocket, and so I've not tried this on a building, so this is kind of a bit of a video that's shot on an iPhone by one of our civils guys who was doing some site survey information, and basically you can shoot the survey in your phone and it gives you pretty accurate information. But that's that the technology is shrinking. So whereas previously you would have had to have done that on a hired professional firms to go in and do that, you can now start to get a really high level scan of actually what's there. So if we put that into buildings, you can start to look at actually what's there in terms of the building, where are the column layouts, and then you can start to try and build sort of indicative models and very rapidly start to pull out what is the opportunity to go up on a building. And a lot of using kind of Revit and other various digital tools, you can start to really rapidly get an idea of what the massing might look like. You can look at what grids might be suitable for different uses, and it starts to give you an idea of what the opportunity could be to refurb and reuse before you get to the point of demolition. So that technology is as I said, it's becoming scanning technology is becoming much cheaper and much easier to use, and so there's those kind of opportunities which we can take hold of, and definitely I think personally I'm quite interested in the LiDAR. We've only just really started playing with it recently, but the LiDAR scanner in your pocket to me seems like a great opportunity for us to be able to realize refurb opportunities in buildings really very rapidly, to look at the opportunity for them. One of the sort of biggest tools that we've got, and I mentioned before, is parametric design, and that enables us to really set targets for what we're trying to achieve. So any kind of parametric problem exists around 3 things. So one is the things that you can vary. So what in your design, what is a variable parameter, for instance, building height, the grid spacing, your floor to floors, materials, anything like that could be a variable that you can alter as part of the design. You set your constraints. So your constraints, obviously, you may have a maximum height of the building. You may have a in-ground constraints where you can't actually put any structure down. And then what your objectives are. So, and that's really where the opportunity exists for us trying to drive towards better sustainable outcomes. Is we need to think about what the objectives are in our design. So are we kind of driving to having, do we want to minimize wastage on site? Do we want to make, ultra efficient structures? But if we do that, are they going to need a significant number of temporary works to construct them? So we need to start thinking about, what objectives we want to set. And very simply, to put it in some context, if we do a sort of simple truss, you've got a huge number of variables in a truss, but you can then start to vary all those things, and building in equations and things into and algorithms in it can almost gives you a live feed out of actually what the structure needs to be as you vary things like truss depth and height, and you can start to try and optimize designs. And this is only a simple truss, but if you start to do that on a much more site-wide scale, you can start to ID much better opportunities. Also, parametric design enables you to rapidly go through different options. So you can start to very quickly go through and alter options depending what your parameters are. And then once you've kind of honed in on a rough concept, you can put that into genetic algorithms, which then start to, within a series of constraints. So if you lock things to grid, they'll start to give you the most efficient structural system or structural solution you've got to whatever problem that you set it. And that's really starting to drive down material usage as well. And you're trying to find, reduce as much as you can the amount of quantity of material that you're trying to construct with. And you can kind of put that all together into if you start to look at a site in itself, and I know, so you guys had Prism presented to you a wee while ago, which is kind of, again, looking at site opportunities, but quite rapidly you can start to say, if I was going to take any site and look at the opportunity on that particular site, you can actually start to play around and pull out material quantities and looking at different arrangements of the building and pulling together carbon quantities and everything else, and it enables you to make decisions about what you can do and what the site opportunity might be on your particular site much more easily, and making informed decisions as well. So you've got some kind of idealized conceptual design straight off. And it goes on to crane optimization as well. So there's opportunities around looking at the construction sites themselves and saying, actually, can you, and again, this is all on parametric design. It's depending on what your parameters are, what are your constraints and what are your variables. So if you start to look at a site in itself, how can you try and work out what where's the best positions for your cranes and everything else across the site. So, and again, this is down to trying to reduce construction program in order to reduce time on site, really, because that's reducing our impact of the construction phase itself. One of the things that I've often thought, we use, and a lot of you have seen parametric design, and it's often in various industry magazines to try and realize complex geometry, and it's used for very interesting and complex buildings and those sorts of things. One of the biggest, I suppose, missed opportunities in my view is we're not really using it on the sort of your kind of bog standard resi building, of which we build a lot of, and these are fairly standard reinforced concrete buildings, and from a structural point of view, we take an architectural layout, and by very much by experience we will come up with a column layout which suits based on a rough grid, which we know will give us a workable flat slab solution or PT solution, and that's kind of where we stop, really. And then there's some minor tweaking that goes on from a coordination point of view, but there's actually better opportunities in there which we're not necessarily realizing yet. If we actually think about that floor plan in a bit more detail, all of those columns can move. They can move within a partition wall. But to try and identify actually what the best arrangement of all those columns would be, in order to minimize slab thickness and reinforcement would take, a person would take us a very long time to actually do as an exercise from a design point of view. Whereas if you start to use, digital algorithms to do that for you, you can actually start to run hundreds and thousands of different iterations, moving all those columns 100 millimeters at a time to try and minimize the slab reinforcement. So, running this through to try and again, this is where you set your target. So if you set your target to try and minimize stress in the slab, it'll find you the most optimal outcome for those column layouts to minimize that, whatever the target that you set is. And this is just as a quick example on a residential building, and by letting it go and letting the computer find the answer, we came up with sort of a different, so if you look at the initial design, you've got quite highly stressed bays. That stress gets reduced in the optimal design, which is saving 7% of reinforcement. And more importantly, it's actually saving 15% reduction on the edge deflections, which actually makes your facade jointing much easier. So it's not just the structural impacts of that, but it actually goes on to actually other disciplines as well, and other materials. And you can run that through element optimization in terms of looking at trying to can you minimize the number of piles that you can put in given by varying different sizes. If anybody's interested, there's quite an interesting paper that was written on topology optimization of beams. So if we look at a steel beam, at the moment we put circular holes in to try and get for surface penetrations. But actually quite a lot of a steel beam is, and especially a concrete beam, is actually wasted material from actually what it needs to be. A fully optimized beam looks like that. I think the fabrication of that is probably going to require more embodied carbon than you actually save in the wastage. But maybe one day we are going to go towards that, where actually we start to 3D print materials, we fully optimize them, and from an MEP point of view, obviously we have to coordinate that, but there are opportunities out there to use the technology we've got to try and reduce the materials that we have in our buildings, if we can. I'm not going to dwell too much on componentized design, because I know that opportunities exist around that. So Prism, you guys have seen before, but if you haven't, I would recommend looking at it. It's there's a lot of technology being used at the moment to actually try and optimize modular design and componentize. So it has significantly speeds up construction using offsite construction. And it's also 40 to 50% lighter, which is one of the important things. That's not just a knock-on effect on the material itself, and that you're reducing the amount of material you've got, but also that reduces foundations, it reduces the core requirements, it reduces all kinds of things. So there's definite opportunities, to optimize buildings using modular, if we can, and bringing in more modular systems. And you get out of the Middle East at the moment, where they're mandating that buildings must be modular, and that kind of the sort of client-led mandates actually are driving the industry to come up with better, faster, and more efficient ways of doing it, and driving us to collaborate as an industry together. So being driven from the sort of clients and contract side as well, I think is a good thing, because it forces us as an industry to actually put our heads together and come up with a better way to build, which is going to be really important in the sort of years to come to enable us to meet those embodied energy targets. So those are a couple of brief overview opportunities around the design side. The data analysis is a great opportunity as well. So we all design and document in Revit at the moment, and there's a huge amount of data in there. So we keep our building geometry, element sizes and dimensions, material specifications, all kinds of information that goes into the Revit model now. And we can start to withdraw that information and start to use it. So what's in Revit is in effect the raw data, but using Dynamo, you can start to pull that out and extract that data, and then push it into databases. So you can use Excel or SQL databases, and then you can start to pull all that information together using, and this is just an example of a workflow that is hopefully reasonably accessible. So if nobody's tried Power BI, Power BI is a great tool, and is fairly easy to get your head around as well for visualization of data, and it enables you to cut and carve data to show it in all manner of different ways that you can start to use it to make informed decisions. So you can start to pull out things like full quantities across different materials in the building, and then fairly quickly turn that into embodied carbon. So you can actually start to see where your embodied carbon is in the building. So where it's coming from in terms of foundations, concrete frame, steel frame, facade, other bits and pieces. And I suppose the analogy was this is once they started to put the ingredients and the calories and everything like that on food, when we go food shopping, we all started to shop differently. So I don't know about you, but certainly I tend to, especially with cereals, I look at the sugar content in cereals now before buying them. If we start to actually be able to see the embodied carbon in all of our designs, are we going to start designing differently? I would suggest we probably are. So once we get hold of that data, actually, it's there and it's in our faces, and we need to start to address it and actually start to look at whether we can start to minimize it by making better decisions around things like material specifications and other things. And we can also start to look at those things over time. So you can, if you look at how the design progresses and whether or not you're making any decisions, because you may be making design decisions for one reason, but actually they're having a negative impact on your material quantities or anything else. So we can actually start to, again, the more data we've got and the more we can visualize it, the better at the moment, because then we can start to really dig into why we're making design decisions and what the cost benefit of some things are. Because I don't think we're under any illusions that there is a cost associated with going for some of the low carbon options, but if we can see that data and it's there in front of us at a cost of X versus a carbon reduction of Y, we can actually have an informed discussion as a team and make a better decision. And also, this means that we can start to test each other as well. I mean, one of the things that I think that as an industry we should doing, we peer review each other from a technical point of view. We don't peer review each other from an embodied carbon point of view. We tend to raise questions around technical performance of the building and those sorts of things. But very rarely do you get, when I have a peer review that comes from another firm, do I get a question about, is there a better way to do this from an embodied carbon point of view? And I think, we all need to acknowledge that we all need to change that. Certainly I'd be more than happy to be challenged on that if another firm thought that we weren't making the right decision somewhere. I think it's a valid discussion to be having amongst the technical discussions that we also have. Another thing, what do we do with the data off the back of all of this? So once we finish the building, and Madasta is a initiative, was a company that I came across quite recently, which so it's a German company which is building a library of buildings. So the idea behind that, it's sort of the Lego library, but the concept is that when you've sort of built your building, you submit your models and 3D information to the library, and that's then locked until you may not want to lock it anymore. So you may be demolishing the building, you actually want to open up the building to others to look at. And my understanding of the concept of this is that, say you're building a new facility or a new asset somewhere, you can actually look at any buildings that are coming to their end of life, and you could, rather than start to procure your material from sort of raw material and buying it straight from fabricators, you could start to look at designing based on the material that's coming from another building, which is, so you could buy your steel beams and your steel columns from a building which is coming down, because it's part of that 3D data, how long all those elements are. You even know down to the connection details where they may have connections. So you could almost build a sort of parametric model that says, I want to design my building and these are the parameters that I want to use in terms of beam sizes, depths, lengths, and everything else, and see actually what you could come up with. And this it's a little bit future focused at the moment, but I think we're going to get there. We're going to have to get there to a certain extent. That reuse of material between different buildings. Probably sooner we're going to get to the reuse of temporary works. So actually, is there temporary works out there that's coming off of buildings that we can then start to use in new buildings, and better visibility of that, I think, is going to be quite important as we go forward. So just to sort of finish off on that, where are there any barriers and opportunities? So, where I view this is that a barrier is sort of presents us with we need to come up with an opportunity to get around it, if you like, a way to do things differently. Construction phase data. So, at the moment we calculate our embodied carbon in the construction stage usually it's prorated. So, as a whole life, it's done as a sort of 1400 kg per 100k capex. If you drill down into that, there's other you can target wastage, but it's all done on a sort of per capex or per quantity, if you like. So there's not a huge amount of accuracy in the data we're getting from construction sites at the moment. Temporary works, for instance, is one. That temporary works tonnage is often wrapped up in that 1400, but if you've put more steel into your permanent works to mean you don't need any temporary works in order to try and reduce the program, you're almost double counting it, because you're counting it in the permanent works tonnage embodied carbon, and you're then double counting it in the temporary works as part of the sort of bundled up construction embodied carbon. So there's obviously work that we can do across the industry, trying to identify temporary works, get them modelled and put into BIM models so that we can actually start to quantify them as well. Site energy usage, obviously collecting data is going to be important to try and understand, to run a site of any particular size, actually how does what's its actual operational site use. Material tracking and wastage, understanding materials as they come onto site, and then as they go off site, and actually tracking materials and looking at where our wastage comes from. The amount of wood that we go through on construction sites is quite significant for formwork and other things. So, anything we can do to try and sort of reduce that load on timber and ply and 2x4s, I think would be a good thing. But we need to understand actually where the wastage comes from first. And then vehicle usage. And logistics. I'm not going to let this run through, but VDC and visual design and construction actually is enabling us to do a digital run through of the construction to try and identify any pinch points. And the more we do that, the more that technology gets adopted across different projects, is going to enable us to try and prevent any delays on site, and the quicker we can get on and off site, the better, because we're reducing the actual embodied carbon from the site as well. Building instrumentation is one. So I'll brush these a bit quickly because I'm running out of time a little bit. But if you think about most offices, we're probably somewhere around, at the moment, the way we work, around this one here, which is comes out at 1.7 kPa. We design all offices for this. So all our offices are designed for very high loading, and that's code driven. So at the moment, but to put that in context, while individual floor plates could be overloaded, and we do need to design for that on individual floor plates, the foundations off the back of that are, once you track all of that load down, even though we do have live load reduction, we are designing for a significant number of people. And for context, we had one project that's in our office, which I think is designed for an occupancy of somewhere around 8,000 people. The foundations could support 125,000 people in the building. But we can't at the moment challenge that because we don't have the data. Whereas if we start to instrument building, understand actually what the loading is on buildings, we can then start to pull information out, and then start to go and have informed discussions around codes and standards, and say, actually, do we need to rethink the way that the requirements for design, in terms of, while it's appropriate to design a floor plate for those high loads, because they could occur on any given base, should we be thinking more about how you track that down the building to the foundations, and how you make decisions around those? So, and that's one thing that we do need data from. Also, we do need to start thinking about, can we start instrumenting buildings, which we're starting to build now, to inform those discussions in 5 or 10 years' time. Industry skills is another one, and I'm actually it's a shame that we can't meet in person, because I would be very interested to talk more with people about how they view the industry skill set, if you like. McKinsey published an interesting article a month or two ago, which was trying to identify the sort of skills for the future, to make sort of people have the necessary skills in the future for the world of work. And one of those was one of their sort of 4 foundational ones was digital, which then is digital skills around fluency, software use and understanding of digital systems. And so I think we need to start thinking actually about non-traditional entry points into our professions. So I was talking to a computational engineer the other day who actually started as a biomedic engineer looking at bone structures. Not a traditional way into structural engineering, but actually he has a huge amount to give in terms of understanding how you optimize structures, because bone is a very optimized structure within a body and it grows according to its loading. So I think we need to start thinking about actually how we're recruiting staff. Are we bringing in non-traditional skill sets into the construction industry to help us hit some of these challenges that we've got in front of us? And also challenging the norm, really. I think, there's digital practitioners, and these are the people that operate the tools and can code. I can't code. I can do a bit of it, but that doesn't necessarily mean that I don't have a place in this. And what we're trying to drive at the moment, and I'm trying to look at in our organisation, is actually trying to get people, rather than saying, well, I can't code and I can't use the tools, therefore I'm not part of this digital revolution, I don't have anything to contribute. Seeing themselves actually, they're more of a digital architect. So they're there to guide the people who are using the tools, because they see the holistic opportunities. They've got enough experience in the industry that they actually say they know where the pinch points are and where the challenges are. And so, they do have a part to play. And so we need to try and bring, from a skill set point of view, upskill the sort of more senior members of the industry, not to use the tools, but actually to understand how they can be of benefit to the people that do use the tools, and try and drive our industry forward. So just a sort of a final thought really from me is this requires collaboration quite significantly. We're not going to solve this as individual companies. So Borough Happold, which I was really pleased to see, release the building and habitat object models. They did this a couple of years ago, and that's basically an open source opportunity or code base, basically, so that people who may not have the, firms that don't necessarily have the skill sets to start building all of the building blocks for digital transformation, if you like, and using digital tools, can actually start to draw on the work done by others and share and collaborate with each other to try and drive, as an industry, drive us forward. And the analogy I kind of have to that is, as Elvin said, I've spent quite a significant portion of my career in New Zealand, and obviously there's a seismic problem in New Zealand, and but as consultants and as companies come across new things and discover new things about seismic design, they share them because it's dangerous not to. And I think we need to almost have the same attitude towards sustainability and the drive toward net zero, because in the context of what we're doing to the planet, it's dangerous for us not to start sharing the good ideas and the opportunities we've got around driving embodied carbon down. And if there's digital tools that are being developed to do that, then we need to share those and help promote those and help train each other into those, if we can, so that we can try and drive much better outcomes for the future industry. And that is me. Thank you.
Well done, sir. Well done, Alex. That was brilliant, mate. Really, very, very good. Highly enjoyable, extraordinarily informative. And so your time is not bad at all there, mate. It's not bad at all. Just you can see a Stephen Page. Well done, Stephen. I'll read it out so you can have a think what he's actually asking here. Interesting to see what parametric design impacts MEP. Now, a design could be optimized for structures, but a reduction in concrete could reduce thermal mass and therefore increase the building cooling demand, for example. So there definitely needs to be a balance. Thoughts, feelings, observations on a very highly articulated observation.
Yeah, and I think, as I sort of mentioned, there's the beauty of parametric design is you can set your targets to be what you want them to be, and the most optimal structural solution is not always, and probably is unlikely to be, the best all project option. So, as you say, it needs to be taken in context with MEP, architecture, facade, everything else, and it comes down to what we set our sort of parameters and targets to be. So And that's where I think, it needs to be a sort of collaborative discussion in the design teams about actually as we try and optimize the design, actually what matters to other consultants. It's not something that as a structural consultant we should be doing in isolation. We should be involving the full design team in that so that we can strike that balance.
Yeah, can I just ask you a quick question? I've got some good questions here. I just want to ask you about that, Alex. Will digital design and visualization, plus the fact we're using far more online collaboration tools, will we actually start to really see collaborative working, which is open, honest, and only setting out for one goal? Because we've been slaughtered as an industry for years for not being truly collaborative. Do you think now it's like the perfect provocation to really collaborate?
I think so, yeah. I mean, I think the technology has got better. If you think, I mean, even going back 2 years ago, our ability to online collaborate has gone from virtually nothing to it's now more or less all we've done for the last 18 months. So in a way, it almost feels weird to get back into a meeting room using a whiteboard. So, and I think that the interoperability between consultants, the technology has come on a lot. As I said, we've got software companies that previously weren't particularly keen on opening up the back door. So Tekla, for instance, we've been talking to them recently about trying to do better or easier interoperability between Tekla and Revit and some of our analysis programs, so that we can quite rapidly go through and rattle through the sort of beam designs in and out of Tekla and take them through on automated workflows. And they weren't particularly keen on that if you go back a couple of years ago, but now I think they're coming round to it's how the industry wants to work. I've had some discussions with architects around can we get better at operating in a sort of a single BIM environment. So I mean, BIM's not my kind of area of expertise, but I think there's definitely I think there's better opportunities now for 3D model deliverables. I know that there's always been this within sort of consultants a sort of reluctance to issue models as deliverables. We give our models out for coordination and things, but at the end of the day, we're still issuing a 2D set of PDF drawings, or which is pretty much the same as when I started, except we used to fax them then. And issue like full A1s by post. We haven't come a long way since then in terms of how we operate from a contractual deliverable point of view. But I kind of feel that reluctance to issue 3D models is starting to break down. Not least because we can actually, the tools that we've got and the fact that we can triage the Revit data means that we can do verification in a 3D environment, so we can get better visibility of what's in the model than we could before. So before, our way of verification was basically to produce the drawings and then go through the drawings. Whereas now I think we can actually start to pull out material quantities. We can start to pull out maps of heat maps of where the tonnages are. So I would like to see more. I'm quite keen to find some trial projects to try and get better interoperability between us and architects and MEP consultants. But I think it seems quite a slow progress at the moment, but I think it is getting there.
Yeah, I would agree with you there. Yeah, I would agree. Ian Farmer, well done, Ian. Two good questions. And so this one's an interesting one. Alex, is the onus on collaboration and monitoring a slightly altruistic view developers should be taking for their own long-term benefit? Or do you see a role for higher education funding there? What do you think? It's a hell of a question.
Is that around, so monitoring for sort of load monitoring and everything else? I think there is a role for higher education.
Yes. Sorry. Yes. Yeah. Thank you, Ian. Mr. Farmer said yes. You're quite right, sir.
Yeah. I mean, I think there's sort of two. Well, the main benefit is that challenging the codes and the standard way of building. I think that the higher education plays a part in that, because there's a lot of research that needs to be carried, and fundamentally a lot of us, from a consultant point of view, we need to, we're all businesses as a developers and architects, contracts, everyone else. We're businesses that need to keep pushing forward, and we need to maintain revenue and everything else. So the amount of time we can spin off into sort of R&D is somewhat limited, whereas actually, you know, bringing higher education into more into the discussion, I think would be a good thing. Yeah, I mean, certainly I kind of hark back to the New Zealand story, but over there, the universities in Auckland and Canterbury do most of the research for the structural engineering firms. So we would often set you know, challenge PhD and master's projects down into universities for things we wanted to find out. Things like it was, you know, as sort of simple as seismic restraint of suspended ceilings and things, because a lot of those fall down in minor earthquakes. And so, you know, we had some PhD students in Canterbury, and there was a couple of requests from engineers, not just mine, but that we basically said we want to know more about how it works and how the building interacts, and whether or not, you know, different kinds of ceilings can actually alter the structural performance of the building if they kind of create stiff points, if they're kind of solid jib ceilings and things like that. And so they had a couple of PhD students that did a lot of research and fed that back into the industry via a conference, and via conference papers and things. So I think there's definitely a role for higher education, and you know, we do need to engage with universities more, I think.
Superb. I love your answer, because I totally and utterly agree, and I'm sure Mr. Garvey would. By the way, Mr. Garvey's let you know that QPR, it's me and me football. Sorry, the QR codes work perfectly. Thank you very much. This will probably have to be the last question, which is a bit of a shame, because actually we get some good questions knocking around. From Rob Garvey is asking very pertinently, what would you, Alex, like to see from COP26?
I don't know. That's a very good question.
Isn't it just? Yeah.
It's quite broad.
It's a fair question, because it's yeah.
I mean, I think I suppose it's the, you know, from it'd be interesting to see what, well, I suppose incentivization would be the best thing, really. I mean, we're I suppose, you know, at the end of the day, we only, you know, as a global industry, if you like, we're altruistic to a point. So, you know, actually, there needs to be some level of you know, incentives and support and that sort of thing, in order to try and actually, you know, try and drive the industry in the right way. I suppose whether that incentive is the carrot or the stick, they both have a part to play. I'm just looking at the next question there, which is
I was going to say, do you want to go for that? Make that the very last. Great question. So that's from Adrian. Do you think there is sufficient incentivization to repurpose buildings rather than rebuild new ones, as only by reusing will we meet the targets? Better make that your last question, mate. What do you think?
I don't think there is at the moment, to be honest. I think there's and yeah, I think we kind of, you know, we're driving development often starts with we often start looking at projects with a sort of clear the site and then what do we build. Whereas, you know, actually, you know, what's the incentive for us not to clear the site, or what's the incentive for us to, if we did clear the site, you know, could we, where's the, you know, what are the opportunities to actually take what we had on the site and reuse it, or repurpose it in some way. And again, that comes down, you know, we need some level of sort of drive, sort of government wide. I mean, I'm not particularly big fan of using, you know, the government sort of driving things as such, but that kind of incentives and you know, them setting some standards in that, I think, would be really useful. You know, you go back to when BIM first became mandated by all government projects, and that was probably the first step into where we are now, where, you know, government almost mandates it for their work streams, and then the industry takes it over, and effectively, you know, the industry owns that as a sort of as a thing now, really. I mean, BIM, you know, we all quite comfortable with BIM, but back when it was kind of in its infancy, if you like, people kind of skirting around the issue a little bit, whereas, you know, it takes that government to mandate something and make, you know, and then the industry starts to change. And I think, you know, doing something similar, as I say, whether it's the carrot or the stick, I think both have a part to play. There's incentives, you know, whether there's tax incentives or development incentives to do that, you know, for reuse and repurposing, hitting embodied energy targets. And then if you don't, there's the reverse. So there's a stick there that's also there if you don't hit the targets.
Good man. Right, Alex, if you could just hold there for a minute. Thank you so much, Alex. I'd like to thank all of our participants this evening. You've been absolutely brilliant as usual. Just there's actually three particularly important notices before we close this evening's session. Number one, our next event is Tuesday, 12th of October, starting at 6 p.m. Our guest speaker is Chris Allery, Technical Director with Hydrock, who will explain what the new building safety bill means for your building. So it's a highly topical subject. Number two, please. Over the next 3 months, London Construction Excellence will be heavily involved in three major industry events, the Leaf Forum and also London Build, which shall be both physical and virtual events, plus the Year in Infrastructure and Going Digital Awards, which is an online event. Now, full details will be available on our website next week. We'll let you know all about that. Number three, please would you be willing to respond to Arne Kelly's email on feedback from this evening's event? We promise we do everything we can to use your comments to continually improve our product and service to meet your needs. We shall be immensely grateful if you would provide this feedback for us. Please, many, many thanks in advance. So to round up, a huge and incredibly grateful thanks to the hard-working London Construction Excellence Management team, the largesse and technical wizardry of the team at SIAD, who co-produced this evening's event, plus your very, very good selves for participating this evening. Thank you. And many, many thanks once again to our wonderful guest speaker, Alex. Did you enjoy yourself, my friend?
Yes, that's very good. Thank you.
Thank you, mate. You did a brilliant job. Good night, everyone. Look forward to interacting with you all again in 3 weeks' time. Thank you and good night.
Thank you all.